We're starting chapter 3 with section 3.1, which is titled Identify Pairs of Lines and Angles. Identify pairs of lines and angles. And we're starting out with several definitions. We have kind of a lot of definitions today. Parallel lines, hopefully that's a phrase you're familiar with. The formal definition, two lines that do not intersect. Hopefully that part we're familiar with. And are coplanar. Parallel lines, yes, they don't intersect, but they also need to lie on the same plane. The skew lines also do not intersect, but skew lines are not coplanar. So parallel lines and skew lines, neither of them intersect. If they lie on the same plane, they're parallel. If they do not lie on the same plane, they're skew. And parallel planes are simply two planes that don't intersect, as you would expect. As always, if I'm going too fast, pause it, give everybody a chance to write and get caught up, and then restart. So our first example looks like this. It gives us a cube. It has identified all the vertices of that cube. Vertex A, B, C, D, E, F, G, H. In that order. And it asks us a few questions there. We are asked to identify all lines that are parallel to line CD that contain point A. We need all lines that are skew to line CD and contain point A. Lines perpendicular to CD that contain point A. And any plane or planes parallel to plane EFG that contain point A. So again, we've got our cube. They've labeled all of our points. They ask us several questions here. So parallel to CD. So parallel to CD means it needs to not intersect CD. And it also needs to contain point A. So point A is over here. Here's point A. So we notice we have several lines that are parallel to CD, like EF. Line EF is parallel to CD. It doesn't cross it, and it lies on the same plane. That plane would be this plane CDE, this side right here. They lie on that same plane. But that doesn't contain point A. AB, line AB does, though. If I were to draw a line through AB, it would look like that. Notice those lines are parallel, and they both lie on this plane, the top of our box there. So line AB does. And notice that's the only one that does. GH would be another one. GH is also parallel to CD and lies in the same plane. It's not one of the sides of the box, but there is a plane that goes through this and down here. If you can kind of picture that plane right there. That plane contains both those lines, and this line is parallel to that one there. But again, that one does not contain point A, so that's not what we're looking for. Line AB is the only one. I need something skew to CD, so it doesn't cross it, but is not parallel to it. That contains point A. Notice this line right here, HA. They're not parallel. They don't lie on the same plane. But they don't cross each other. So CD is here, AH is going this way. Those are skew. That is the only line that is skew to CD that does not, or that passes through point A. Another one would be BG. BG is also skew to CD. Perpendicular to CD and containing point A. So perpendicular, I need a right angle in here. Notice this line right here, assuming I've got a rectangular prism. It doesn't, based on our figure here, it doesn't appear to be right necessarily, but we know with a rectangular prism, we're going to have a right angle in there. It should be line AD. Again, BC is also perpendicular. This containing point A is eliminating that. There's a couple more skew lines down here also. EH is skew. Notice doesn't pass, but does not lie in the same plane. FG also is skew. None of those contain point A though. And then we need a plane that is parallel to plane EFG. So EFG. EFG is the plane that is the bottom here of our rectangular prism of our box. The one that is parallel to that contains point A would be the top of the box, right? That plane runs parallel, never intersects with the plane down here at the bottom. We name planes by naming at least 3 points on that plane. Looks like A, B, and C are all on that plane, or A, B, D, or B, C, D. There's lots of ways you can name it. A couple more things we need to talk through here. We have the parallel postulate as well as the perpendicular postulate. They say exactly the same thing except for one word in the postulate. The parallel postulate says if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. So we've got a line and a point that does not lie on the line. We only have one parallel line that passes through that point. So I could draw lots of lines through that point, like that line there, but that line's not parallel, right? There's only one. That is the only line that exists that passes through the given point that is parallel to this line. And the same is true with perpendicular lines. Again, these say exactly the same thing outside of this word right here. If we have a line and a point not on the line, I've got a line, I've got a point not on the line. There's only one line that passes through that point that is perpendicular to the given line. Only one such line exists. So going back to that last example, we were asked for a parallel line to CD that contains a point. There's only ever going to be one here. There is only ever going to be one right here. Now that's not true for skew. We don't have a skew line postulate. Notice this wasn't one of the lines on here, but like AG or EA pass through A, but are not parallel to CD. So skew lines, that's not the case. But with parallel and perpendicular lines, if I'm given a line and a point, there's only one such line that is parallel or perpendicular to the given line. Lots more definitions. Look at all them. The first one is a transversal we will be working with transversals a lot, especially here in chapter 3. A transversal is a line that intersects two or more coplanar lines at different points. A line that intersects two or more coplanar lines at different points. So I've got two lines. They could be parallel. They don't have to be. I'm going to draw them parallel here. There's my two lines. A transversal intersects both those lines at different points. We could have two parallel lines. Those lines don't have to be parallel. They could look like this, and then there's a transversal. These are lines, so they extend on. I'm not going to draw the arrows at the moment, but the transversal could be perpendicular to one or both of them. That's possible. But this line right here that passes through the two given lines, that is called a transversal. When we have a transversal, we are going to have a bunch of different types of angles. So I've got a transversal cutting through two given lines. Corresponding angles are in the same position relative to the transversal. Corresponding angles, same position relative to the transversal. So I've got my two lines with the transversal. So this angle right here is in the top left. This one right here is the corresponding angle, top left, relative to the transversal. That angle and this angle, top right, those are corresponding angles. This one here and this one here are called corresponding angles. I guess I marked them 1 and 1. That indicates that they're equal to each other. We don't know that. They don't have to be equal to each other. We'll talk a lot more about that here soon, but notice now they're definitely, this angle here and this angle here are not equal to each other. So go with the colors, not necessarily the, hey, this and this are the same. They look the same at the moment. So corresponding angles, same position relative to the transversal. Alternate means they're on opposite sides of the transversal. Alternate, on different sides of the transversal. So like this angle and this one or this one are considered alternate. This one's on kind of the top of the transversal and these two are under the transversal. Exterior means that they lie on the outside of the two lines. These are all exterior and these are exterior. This one and this one, this one and this one. And interior means it lies between the two transversals. Exterior, outside the two lines. Interior, did I say lie between the two transversals? The two lines, not the transversals that lie because we will talk through, usually we don't just talk about alternate angles or exterior angles or interior. Usually we'll put them together and we'll take a look at what that looks like. Alternate exterior angles, alternate interior angles, opposite sides of the transversal and between the two lines, or opposite sides of the transversal and outside the two lines. And then the last one is consecutive angles. Consecutive angles are between the two lines, so they're interior, and on the same side of the transversal. Consecutive angles are between the two lines and on the same side of the transversal. I'll scroll back down in a minute. So inside the lines, but on the same side of the transversal. The two red ones here are corresponding. So get caught up on your definitions. We're going to take a look at one more example, and that'll be it. Example 2 asks us to identify all sets of corresponding angles, alternate exterior angles, alternate interior angles, and consecutive angles. So corresponding means in the same spot relative to the transversal. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Two lines. Transversal cuts through those two lines. It intersects them at two different places. Corresponding angles, same spot. So angle 1 and angle 5. Notice 1 and 5 are both on the top left. You find the rest of them. Top right would be 2 and 6. 3 and 7. 4 and 8. Next one it asks for are alternate exterior. Exterior, so we're looking at ones that are on the outside. So 1 and 2 are exterior, 7 and 8 are exterior. I want them to be alternate, so on different sides of the transversal. 1 and 8. 2 and 7. And again, this is bad notation on my part. When I did 1 and 1 here, those are not equal to each other necessarily. They might be. So 1 and 8, 2 and 7, those are the ones that are alternate exterior. I suppose I should maybe circle them instead of drawing in that little. Angle 2 and angle 7, alternate exterior. Alternate interior, inside the lines but opposite. We've got 3 and 6, 4 and 5. Different sides of the transversal, but between the two lines. And the last one it asked for is consecutive. Consecutive means interior, so inside, but on the same side of the transversal. 3 and 5. Interior, both on the left side of the transversal there. 4 and 6 are the other ones. That's it for today's notes. Reach out with any questions you